Plastics. Plastic is a substance that has permeated into every imaginable sphere of our lives. It is present in electronic gadgets, computers, televisions, home appliances, hospital equipments, automobiles, aeroplanes, rockets, and even in satellites. This is because they are strong, durable, versatile, and still very affordable. Due to this, the demand for plastic is escalating exponentially. Its annual production is now over 100 million tons globally, and this figure is increasing by around 10% annually. The raw material for most plastic substances comes predominantly from hydrocarbons, which are found in natural gas, oil, and coal. Perils of plastic. Plastic unfortunately has an ugly side to it. It is becoming one of the world's biggest sources of environmental pollution, as it is a non-biodegradable substance that turns toxic over time. Recent studies have revealed that the huge patches of plastic waste floating in our oceans, if put together, could add up to the size of Australia. Imagine that! This is affecting not just marine life, but also the lives of those who live off them. Since sea creatures are not exactly discerning in such man-made maladies, many of them end up ingesting parts of these plastic wastes, mistaking them for food. This makes them sick and many develop tumors. Such sick and tumorous seafood can be dangerous for those who consume them. In India, cows too eat plastic wastes which have food remnants on them, thinking it is food, and fall sick. Plastic wastes dumped in landfills cause soil pollution and loss of soil fertility. When incinerated, it emits toxic fumes which pollute the atmosphere. Plastic debris also clogs sewage drains. This creates stagnant water bodies which then become the ideal habitat for mosquitoes and other parasites to breed in. These choked drains contribute to flooding during monsoons and rainstorms, as was seen in Chennai recently. Solutions. Fortunately, scientists have now found a way of converting plastic wastes into fuels which have commercial applications. This will induce people to collect and sell waste plastics to the companies producing oil from it. This resolves the problem of plastic pollution and also creates a non-fossil source for fuel. For instance, around 60 lakh barrels of oil can be produced from the 50 billion plastic bags disposed annually in India alone. It is in this context of waste plastics wreaking havoc in our precious planet's fragile ecosystem and our nation's urgent need to find an alternate source of fuel that Mr. Kalandur, the founder of the Kalandur Group, started the new venture, Kalandur Green Energy, KGE. The Swachh Bharat initiative has on its part provided an additional impetus to this mission of KGE to make India cleaner and greener. KGE has built a state-of-the-art plant at Baikampadi in Mangalore, where plastic waste is converted into fuel on an industrial scale through the process of pyrolysis. Let's see how this works. Production process. End-of-life plastics of various types like polythene covers, polypropylene chips, food containers, etc. of various shapes and sizes are fed into the shredder. This operation is done manually. These shredded plastic pieces are conveyed to the loading hopper through a horizontal conveyor followed by a Z conveyor. A suitable quantity of proprietary and patented catalyst is added to the shredded plastic in the hopper. This mixture of shredded plastic and catalyst enters a rotary kiln pyrolysis reactor made up of SS304 material with the help of a screw feeder. An average loading rate of 300 to 400 kilograms of plastic can be achieved per hour once equilibrium is achieved. The pyrolysis reactor, having a spiral inside to push the material to the other end when rotated, is heated externally to a temperature of 600 degrees Celsius with the help of 3 dual fuel burners kept at equal distances. These operate on pyrolysis oil as well as uncondensed pyrogas. When subjected to intense heating in the presence of the catalyst in this oxygen-free environment, the long chains of hydrocarbons in the plastics start disintegrating and form small hydrocarbon chains of C1 to C16. This process is called thermocatalytic depolymerization of plastics, or in general words, plastic pyrolysis. The non-hydrocarbon inorganic components in the plastics like fillers, external dirt, metals, etc. remain in the reactor as pyro ash, and the same is pushed out into the carbon ash discharge chute. The small hydrocarbon chains generated in the reactor, which are in the form of high-temperature condensable vapors, enters the condensation section of the plant. Cooling water coming from cooling zones help to cool and condense the hydrocarbon vapors in the condensers, and as a result, C5 to C16 fractions become liquid and is collected in the receiver tanks. There will be a few hydrocarbon chains having C1 to C4 fractions, which will escape the condensation process and come out as pyrogas. These gases are now used as an alternate fuel for the burners in the place of expensive liquid fuel used to externally heat the reactor. If the pyrogas generated is more than what is required to heat the reactor, the excess gas is sent to a flaring chamber where it is flared up. The flue gas generated in the furnace is sucked out with the help of an exhaust ID fan through a scrubber to remove impurities and particulate matter in order to meet PCB norms, and then it is let out through a 40-feet chimney. The liquid fuel collected in the receiver tank is pumped through oil filters and sent to the storage tank kept outside the factory shed. The ash discharged from the reactor is cooled and conveyed to the storage bin. Applications. This oil created from waste plastics can be used in almost all thermal applications such as boilers, furnaces, hot air generators, cement kilns, lime kilns, and any other application where liquid fossil fuels such as HSD, light diesel oil, or furnace oil are normally used. With advanced distillation techniques, this fuel can be converted into Euro standard gasoline, diesel, and jet fuel. The carbon generated in the final stage of the pyrolysis process can be used in foundries, paper and pulp industries, cement plants, and thermal power plants. KGE is now successfully marketing this fuel in the city of Bangalore. It is being sold to corporate clients like hotels and hospitals who take pride in replacing fossil fuels like HSD with this green fuel for their steam boilers. KGE is a division of the Dubai-based Kalandur Group. This group was established by Mr. Kalandur in the year 2000 and has operations in India and the GCC countries. The group has been providing high-quality solutions in the diverse fields of construction, interior fit-out, furniture manufacturing, retailing, general trading, and green energy solutions. Conclusion. In a world that is increasingly bearing the brunt of global warming and climate changes triggered by the ecological imbalances caused by human greed and excesses, finding sustainable solutions are no more a matter of choice. That is, if we are serious about our survival on this planet. It is with this clear realization that KGE has chosen to join the worldwide campaign to resolve the problem of waste plastic pollution and in the process reduce our nation's dependence on fossil fuels by converting waste plastics into fuel.